So or the window, the phone, the one closest to the phone, door, window, phone. I don't know what I'm doing. Okay. The worksheet 4 is what we're starting with because we started talking about properties of logs Friday. We had school Friday, right? Okay. So we reviewed these ideas that when you have a single log that says multiply, you can separate into 2 logs with addition. A single log that says divide, you can separate into subtraction. And anytime you have a power out here, you can move it to the front as multiplication. Okay, those are the 3 things you need to have memorized. But then it got kind of complicated. You already have this worked out on your paper, okay? This is example 2 at the top, and we kind of skipped it on Friday because it was worked out and we felt like we knew what we were doing. But this is one of the most missed questions on the quiz, okay? This is 6A, 6A. Example 2 on 6A. Find it? Okay. The issue that students have, tell me how to start this. Expand. So we have ln of, okay, and then it says times, so we go to plus ln of x to the 5th, and what can we do with that 5? Okay. Now we have divide. So we do minus ln of, okay, then it says multiply. So if we switch to ln of y squared, we can move the 2 out here. Is that going to be right? Why or why not? As an addition problem, I could do that in any order I wanted, right? So it would be okay for me to go then we have to fix it. Because right now it's okay for me to do it in any order I wanted. So these 3 things would all end up in the numerator. How are we going to say that's not right? Yeah. How are we going to make it so these things stay in the denominator right here? Okay. We could definitely do parentheses there. So you're going to multiply a 3 times a y squared, and then the minus means it all goes in the divider's denominator. Is there anything else we could do then? If you can put parentheses, what could you also do? Distribute it, yeah. So you could say ln of 8 plus 5 ln of x minus ln of 3 and minus 2 ln of y, because both of these things are in the denominator. Okay. They either both have to be minus or you plus with the parentheses. Either one I'll take. But if you leave this just a plus with no parentheses, it belongs in the numerator. All right, so I want to make sure and hit that today. One more. Well, let's skip the easy one. I think we got the easy one once I'll multiply. Are we good? Let's try this disaster. Anybody want to try this? Do you remember what we talked about with a plus that's already there? Yeah, you can't do anything with it. I had this slide, remember? Can't distribute a log. So this quantity up here, because it's a plus, it glues it all together and we can't do anything with it. So we're going to have ln of 3y plus 2. Then what? Okay, good job. I appreciate that you realize this should be a power of 1/3, but it's not on the 4, right? It's on the y. So we could think about this as a 4 to the 1/3. I would like you to do that. But it's multiplied, right, by that 4? Anybody? okay? But that's not going to be completely expanded. Yes, but it's not on the 4. We need to separate it from the 4. So we have the log of 4, then this is times, so we need to do, you could do subtract because it's in the denominator, or you could put a parenthesis here and say addition, okay? Then we'd have y to the 1/3, and the 1/3 could go here. So you could either move it and leave the parentheses, or you could do 3y plus 2 minus ln of 4 minus 1/3, sorry, I didn't squeeze it in there, ln of y. These both belong in the denominator then. Okay. All right. Let's do a couple condense. Remember when it says condense, you want to write the word log once. Okay. So this is log base 2. Any ideas? Where does this 5 go? It goes in an exponent. And where does this 3 go? Okay. Plus means, then we have this messy 6x to the 3rd. Okay. I don't want a negative exponent. What does that mean? It means it belongs in the denominator. Could I have moved minus the 5 log whatever back here, which would have told me it went in the denominator, right? Minus means, okay. So we have log base 2. The x plus 1 to the 5th is going to go in the denominator. I don't really care, but could we get rid of those parentheses? Yeah, x plus 1 to the 5th. Need more coffee or something. That was bad. All right, x plus 1 to the 5th. Thank you. What could we do with this? It goes in the numerator because it's a positive exponent. We could make it an x to the 3rd. And what is 6 to the 3rd, guys? 216 maybe? Can someone check? So we could do that, or we could have just left it 6x to the 3rd. I don't really care. All right, last one, and then we'll do the ones you have on your worksheet. ln 1 time 3x plus 5 goes where? Top or bottom? Okay, what does this do? Yeah, it means it's going to be divide, and it's a exponent. So what is a negative 4 going to do? Or it's just going to be an x to the 4th down here. And this one? Yes. Yep. I'm trying to think what that would look like. Like this, I should have just moved the 4 here, and then it would have gone in the bottom. Otherwise, if you made it a plus and a negative 4 here, then you would have written it maybe here and then said, oh, wait, it goes in the bottom. Is that a little better? All right, guys, you have these on the back of 6. We're practicing this one more time, and then we're moving on to the new stuff. You have these on the back of 6. Somebody help me expand 9. Okay. Yep. Minus is good. Yes, square root, I want you to change back and forth between radicals and fractions. This is the 1/2 power. So DeAndre said 1/2. Then we can move it out front. So we'd have a 1/2 ln of because it's just the quantity. We can't mess with the quantity with the plus. As long as we're leaving it in the parentheses, we're not messing with it. Okay. And we can't separate this because it started glued together. Okay, what about 10? Log base 2. Do these giant parentheses doing us anything? No, it's just multiplied. Okay. What are we going to do with that 3? You can move it to the front. Okay, now we have a 2x. Then times would be, and we'd have log base 2 of x plus 1. Is that completely expanded, guys? Why not? Yeah, this can be expanded. We have two options here. We can either leave the 3 out there and write log base 2 of 2 plus log base 2 of x. We have about 5 options, honestly. Then plus log base 2 of x plus 1. Or we could have back here simplified this to a what? What is 2x quantity cubed? Yes, 8x cubed. So we could have changed this all to log base 2 of 8 plus log base 2 plus 3 log base 2 of x. What is log base 2 of 2? 1. So we could have just written 3 plus 3 log base 2 of x plus log base 2 of x plus 1. Yeah, too much craziness going on there. Yeah. Not the blue. You have to get rid of the multiply by expanding it further. If you left it log base 2 of 2, I don't think I would ask one quite that complicated. Okay, guys? All right. And honestly, if you've done, yep, the expanding, I'll be fine. So somebody try this one quick. Log base 13 of, what do you want to do? How do you get rid of this top? There's multiplication going on, so we change it to what? Yep, the 4 is going to go up front. Is Kayvon the only one that gets this, or are you all just sleeping? Are we good with the top? Okay, now we have a minus. What exponent power is this? 1/3, which can move out front. And it's minus y again, guys? Yeah, divided, okay. And can we do separate this? 7 times x minus 3? No, plus or minus 8, because it's the 1/3 of all of that quantity. Okay. Yeah, adding and subtracting x like glue. All right, I like condensing better. I don't know about you, it's less writing. So let's do these real quick. What's the 1/2 going to do? Square root. Okay, so I'll just move it like that. And then what's a minus going to do? Divide. And then we have a single log, right? So the square root of 3x minus 5y over the quantity 4x plus y. Yuck. Log base 3 of 8, is that something we should simplify? What does that mean? Is it 2? Log base 3 of 8 means 3 to what power equals 8, right? Does that work? No. If it was a 2 down here, then it would be equivalent to 3, but it's not. Yep. All right, so what are we going to do? Where do you want to start? Can I move this 2? Where could I move that 2? Okay. Now what? What does plus mean? So this will become log base 3 of times x divided by x plus 4 quantity squared. And you could definitely put an extra parenthesis in there to show all that, but so work on 14 and 15. See what you get. Anybody get 14 to a single log yet? What does plus mean? And what does minus mean? So what goes in the denominator? Okay. Does the z go in the denominator? There's no parentheses, so we could change it to any order we want. So we could move log of z squared out front. No, it does not go in the denominator. Okay. We actually have a 3y and a z squared in the numerator and a cubed root of x in the denominator. The only thing that was minus was this. Got to remember, guys, that if you could switch the order around, then it doesn't matter. There's not a distributed negative here, so that this is in the numerator. Questions? What about this one over here? Now this time it is a distributed minus, right? So both of those are going to go in the denominator because it says minus both of those. So we'd have what in the denominator? Plus becomes times, right? Z cubed, yep. And what's up top? X and a Y, which I wouldn't give it to you that way on a quiz, but you could simplify, right? Those would divide out. So I guess the simplified answer would be y over z cubed. Because if we had just distributed the negative, we'd have had log base 3 of x minus log base 3 of x. Would have gone away. I'm not going to ask you one like that. All right, then what do we have? Quick. All right. Intensity of a shock wave from an earthquake is given by this formula, where I sub 0 is 1. So this is just a 1 down here. So to find the magnitude, if R equals 6.7, we have log base 10 of I. How are we going to find I? Guys, what's it mean? No. Log base 10 of 10 is 1. But how could you rewrite that as an exponent sentence? Ten to some power. Nope, we know the power. Yes. There we go. 10 to the 6.7 equals I. All right, and that's not a nice number. 10 to the 6.7 is 5011872. So 5 million something. Okay. The intensity of the shock wave, and what would we do over here? Yes. So 10 to the 7.1. So even though this one is only not even 1 bigger? Is the magnitude or the destructive power much greater? It's 2, 5, 8. I can't put my commas in the right place. Is that what we were given? Is that the number you have on your calculator? So this one was 5 million and this is 12 million. That's why when you hear about an earthquake that has just a decimal point difference, it's like much greater destruction. All right. Wanted to see if we could do this SAT question. There's a part of the SAT that's no calculator. Any ideas what we could do with this? What could we do with this too? Okay. What does minus mean? Okay. And this too? Okay. So we have log base 5 of 12 squared. On the bottom we have 8. Where does this go? Because it's also minus on the bottom, and there's a 3 squared, and it's times. I know that seems weird because it says minus, but anytime you're writing another thing down there, it's times 3 squared. Okay. So, sorry. What's 3 squared? Times 8. Okay. Log base 5 of what's 12 squared? What do you think? 144 divided by 72? It's just 2, right? So this one? Yeah, we're just reducing. 144 divided by 72 is 2. All right, so that would be a good no calculator part because you had to know the properties of logs, okay? And they might have used smaller numbers, I don't know. All right, just a reminder, did you see some stuff on worksheet 7 like this? What does this mean, guys, when you see over 3? Nobody did their homework? Over 3 means 1/3. So then how were we going to write it? Log base 3 of z cubed, nope, times x to the 1/3, which is the cube root, okay? This, I will tell you, you need to write it as a cubed root, yes. These are both to the 1/2. So they are both what? Square root, okay? And we could even write square root of xy because they're both multiplied, square rooted. This is a z that is not, it's multiplied, but it's not square rooted. All right, those are things like worksheet 7, which is like the quiz. All right, we are moving on to talk about the app today. Yes, there is a finance app on your calculator. This is worksheet 4. This is the formula, okay? This is the formula to find the future value of what's called an annuity account, which is when you continue to put money into an account every month. So if you started an annuity account of some kind and you're putting in, say, $100 a month, because I want to retire in 15 years, so I'm going to start saving $100 a month into an annuity account. So the account grows, but the amount of interest you earn is based on what's already in the account every month. Does that make sense, guys? But it's also growing. So the formula is very complicated. It says the payment times blah, 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 blah. You want to have to type that in your calculator with a whole bunch of zillion parentheses? Because it would need a zillion parentheses, okay? Our calculator has programmed in what's under the finance app, what's called the time value of money solver. It is a solver, meaning you can solve for any piece of information in the app. All right, to find this, two things. These are the abbreviations of what we're going to see, and they are on your pink sheet. Okay, if you have your little pink, isn't it pink, the half sheet? Okay, yes. Across the bottom, doesn't it tell you what these stand for? Okay, so you do have reference to this, but you have to still know how to use it. All right, to find it on your calculator, it is the apps button, not the programs button. Right next to math, it says apps. It is the first app in every Texas Instruments calculator when they leave the factory. And you hit enter, and then we're going to use the solver. So we're just going to hit enter again. So it's apps, enter, enter. Did everybody get to this screen on their calculator? Now you might have some stuff in there already. That's fine. We're just going to type over it anyway. All right, now what these stand for is on your sheet. N stands for the total number of payments or compoundings. I is interest, but notice it says percent. You don't change it to a decimal, you put it in as a percent. So if it's 2.5%, you put 2.5, not 0.025, okay? Put it in as a percent. P stands for present value. PMT is payment. FV is future value. P per Y is payments per year. C per Y is compoundings per year. Everybody needs to have this default set to end. Is everybody set to end? Because it will totally give you a different answer if you set it to beginning. This means I'm making a payment at the end of the month versus the beginning of the month. Its default is end, so we're all just going to leave it there. Everybody good? Anybody not at this screen? All right. So I'm going to try some questions here. Okay, it says on the pink reference sheet, okay, these things are what they stand for is, but you need to know how to use them. I'm not going to help you during the quiz, because that means you didn't do any of the practice. So our first example says an investor pays $600 quarterly into an annuity. The annuity earns 7.2% annual interest. What will be its value after 15 years? You know you have to use the finance app when it says anything about making payments. Okay, if it just wants the future value of a compound interest savings account, we have a formula for that. If it wants to know how much it's going to grow with continuous interest left alone in an account, we have a formula for that. But if we're making payments, we need to use this app. All right, so he pays $600 quarterly. So what is the $600? Anybody know? It is the payment. Quarterly would be how many times a year? 4. So he's making 4 payments a year. The annuity earns 7.24% annual interest. That is the I, and we don't move the decimal, 7.24. What will the value be of the annuity after 15 years? Okay. N has to do with time, but it's actually the number of payments. So we want to do 15 years times quarterly. And it is 60, but it's so nice because you can type that in as 15 times 4 there. Because when it's like 15 times 25, we don't know that off the top of our head. It'll let you just type it in as a multiplication problem, okay? The present value, they're starting with nothing, their account, and we want to know the future value. So this is where we're going to put our cursor and tell it to solve in a minute. Compoundings per year is a little vague on this question. I'm going to go with 4. Every time they make a payment, they compound the interest. It defaults to that. I think you can override it, but yeah, it defaults to whatever you put in for payment. It changes the compoundings to the same. All right, so for N, I'm going to put 15 times 4. As soon as I hit enter, it changes it to 60, but I just want you to know that's a feature. You don't have to know that before you put it in. It'll do it. This was 7.24. Present value, we're starting with nothing in the account. Going to open it, and then we're going to start making payments of, was it 600, guys? Yeah. Okay. Future value is what we want to find. We're making 4 payments a year. As soon as we hit enter, this changes to 4 as well. All right, so now you go back and you put your cursor where the future value is. How many of you have seen the word solve on your calculator and wondered, why can't I ever solve anything? Yes, it is down at enter, it says solve, right? That's what we want it to do. We want it to solve for the value where our cursor is. So we're going to use alpha. Be careful because I start typing second enter and I can't figure out why it's not working. It's alpha enter for solve. Now, the future value of this account is $64,102.91. Is this already done on your worksheet or not? No? Okay. Why is it negative is always a question. The program, guys, think about this. The program has to be telling a difference between whether you're giving the bank the money or the bank's giving the money to you. Okay? If we had gone up here and changed this and put it in as a negative 600, when we went down here, this would have turned out the exact same amount, but positive. That's because the calculator has to have a way to indicate one was your money going in and one is your money coming back out from the bank. Okay? So it doesn't matter which way you put it in, as long as when you write down the answer, you tell me the value of the account is now positive, right? I don't care if it says a negative on your screen. The value that this person has is $64,102.91. Now, just humor me. Do you know how to get out of this on your calculator? Okay, so second, clear to quit. They put $600 in 4 times a year for 15 years. So they entered $36,000. I just want you to see that it's not all interest, okay? They put in $36,000, but it grew to 64 because some of it's been in there a long time, earning interest. Make sense? All right. Oh, is it done here? It is done here eventually, right? On your screen? You have that or not? Okay. Well, we got the right answer anyway. All right. I didn't ask any on the quiz about a down payment, but a down payment would come off the top of a loan. If you bought your house for $100,000, you put $5,000 down. Now you'd only have to borrow $95,000. Okay. But when you go to figure out how much your payments are going to be, that's a huge issue, right? You guys all want to buy a car someday. You want to know how much your payments are going to be. Okay. So to find the payment is this, again, very complicated formula, but the calculator will do it for you in the same place. All right, you borrow $170,000 from the bank to purchase a home. It's a 30-year loan with an annual interest rate of 4.5%. Calculate your monthly payment and the total paid after 30 years. This question's on the quiz, and students can do the monthly payment and then they don't remember how to get the total paid, which should be the easiest thing ever. But if we go to the calculator, you guys have this question in front of you, so you can help me fill this in. Okay, app, enter. All right, wasn't it a 30-year mortgage? So do we put 30 for N? What does it say on your pink sheet? Does it say payments, total payments or something? Okay, payment periods. Okay, so we're not going to just pay this 30 times. We're going to have to pay it 30 years worth of monthly payments. So we have to do 30 times 12. 360 payments. Everybody good? What was the interest? I have no idea. 4.5. And we don't move the decimal for this program. Present value. So you went to the bank. How much did you borrow? Okay. You can put it in as a positive or a negative. It doesn't matter, but you're going to get the opposite sign on your payment. Okay? $170,000. What are we trying to find? Yes, the payment. So eventually you can zero this out if you want. It doesn't matter. We're going to go there. Okay? But it won't let me go down, I don't think, till I have a number there. So I'm going to find that. Future value, guys. What do you want the future value of this loan to be at the end of 30 years? Zero. Future value, you want it paid off. All right. And we're making monthly payments, so we're going to put 12 payments a year, and that will default this to 12 compoundings a year. So where do we want to put our cursor? Okay. We want to figure out how big the payment's going to be. So it doesn't matter what it can have a number in here already. It doesn't matter. As long as all the rest of the numbers are right, it will solve for this. So it's alpha, enter, and we need a payment of $861.37. Now, you probably don't know this about a loan, but the very last payment of any loan is usually off a few cents. And that's because of this rounding issue, okay? It used to be we would get a paper payment book. I don't think very many people get a paper payment book anymore. But I would have to rip off a stub and send it in with my check every month for my payment. And then when I got to the very last one, there was a note that said, see the bank to make your final payment. Okay. Now they just do everything electronically. I get that. But the last payment is always off a few cents. So we have $861.37. I would say we should call that. All right. $861.37. Now, you don't write it down as negative. You could have put the $170,000 in as negative, and then this would have came out positive. Did anyone not get this answer? All right. How do we figure out the total we paid for this house after 30 years? $861.37 every month for 30 years. That's it. I'm going to tell you now, it's usually twice what you borrowed, depending on the interest rate and how long you take it out. What did it come out this time? 310. Okay. So 310,000 for 107. So not quite twice what you paid, right? It's a lot. You pay a lot of interest when you borrow money for 30 years, no matter how low the interest rate is. Okay. So just beware, because what students will do is they'll just multiply by 30, and they tell me that they paid the loan. What's 861 times 30? Someone do it real fast. Okay. Can you pay the loan off for $25,000? You borrowed 170, okay? Make sure it's a reasonable answer. All right. These are the questions that it asks on these. Calculate the future value. Now, if it's an annuity, okay, means you're making payments. This is off the actual homework. All right. And then there's these. Calculate the monthly payment and total amount to be repaid. Rather than starting on the back side, let's do a couple of these. You have to do 1, 3, 5, 7, 9, and 13. $13 is long. Let's do one of these. Somebody pick one of these. 1, 3, 5. Okay, 4. Way to go. Pick one that isn't assigned. I was offered to do your homework. You have to do 1, 3, 5. What would you like me to do? All right. It says calculate the future value of the annuity. That means you're making monthly payments of $450. This is your payment. It's not clear on this screen, in my opinion, but they want you to be able to know what an annuity means. You're making payments, apparently. I would have written it as a word problem. So-and-so is making monthly payments of $450 quarterly for 8 years. How much is the future value? Okay. So we are going to have, it starts with N. What is N going to be for this question? Quarterly quarterly for 8 years. Yes, so 4 for quarterly times 8, or 32. I is going to be 5.5. I would highly suggest that you practice writing these down, because if you don't put anything on the quiz and you get it wrong, it's going to be a concept error. Whereas if you wrote this all down and somehow you still managed to type something into the calculator wrong, that would be an oops instead of a concept error, okay? The next thing on the list is present value. Yes, because you're starting with nothing in the account. PMT is $450, or you can put it in as negative. Future value is where you want to put your cursor. Payments per year and compoundings per year. What are we doing there? These are going to be 4. Sorry, I wrote that really messy because it said quarterly. Most of the stuff on the quiz is monthly, guys. All right, so if I had been out of this, again, how do I find it? Okay, apps, enter a couple times. It was 8 times 4, 8 years quarterly. The interest was 5.5. Present value is 0. Payment was 800, guys. 450. I totally couldn't remember. Future value is what we want to find. This, though, is 4 and 4. So the future value, alpha, enter, is $17,936.50. Okay. I'm going to talk about real quick number 7. What would N be? Calculate the monthly payment. 30 times 12. I is 5.5 for this one. Present value. Yes, the 220,000, it doesn't have a slash, sorry, is the present value. The payment is what we're trying to find, so that's where your cursor is going to go. The future value at the end of your loan, guys, it should be 0. And the other two are 12 and 12. Okay? And then once you had the payment, what would you do? To find the total cost. Yes. So if I do this one, $30 times 12. Hey, I'm going to finish this recording, but just so you're aware, guys, your homework is up here. It is to finish 3.3 and start working on this finance stuff. Do page 171, okay? 1, 3, 5, 7, 9, and 13. Yep, totally put that in the wrong spot. Say that again. This should be 0. We're trying to figure out the payment. $1249.14. What's up, Tara? Oh, this is the total cost of the house. All right, so the payment was $1249.14, and the total cost of the house was $449,000 and more. All right.